structure. And then another algorithm being called Rabin Karp algorithm. Both are actually using the hash function. Would say, but we especially will be introduced what's the hash function, what's the problem of the hash function, what's the prof constant hash function. It means this is always it's related to the hash function. By the way, do you any idea of the hash function? Somebody heard about hash function in some lesson, or did you know? Did you heard about hash function before?
Yeah, I heard, but not like I don't remember a lot from it because last time I went through it,
I
it
mean,
was
I'm
long
not
ago.
accepted our lesson. Do you any idea of the hash function of the other lesson? For example, security or I don't know. There is a many lesson actually. There is many field actually use the hash function. That's one thing. Okay. So I will be introduced hash function. Then um, I will be point out the problem. Then there is also one problem. Then we can able to avoid. This is a collision, being called the collision. Then if so that's the reason you will be find better hash function. Actually, there's does less collision. It should be possibly to happen collision, but in theoretically, but if there's in the nowadays they can find a better hash function. So actually, the usage of the hash function to apply the application will be increasing nowadays. So we compare the array linked list to hash function as well. Finally, Rabin Karp, as well as how the implementation. So first of all, let's see hash function. Okay. Before, actually the hash table. Then what's hash function? First of all, actually, our goal is trying to introduce what's a hash table, because actually we know the array, we know the linked list. What's the hash table look like, right? So why we need hash table? That's the first intention, probably. So this is also very important because we know it array, we know it linked list. Actually, both those are actually the linear data structure. We just put it away the non-linear first, because that's linear hash table, also linear data structure. So that's interesting to compare with the array and the linked list. One thing is that when we compare the array and the linked list, they have both has advantage and disadvantage. Link is good at for update, insert, delete is very good at, but array not. Array only for looking and searching is it's very give you very extraordinary performance, but linked list is reverse. So they has both. If you put together, they actually. I'm sorry, I have a little bit. Mhm. There's Sorry. So uh, so basically, that's a hash table is another linear data structure, which is, they have an advantage of the both linked list and the, array list. As you can see, the insert is tended toward, I mean, it's O1. I mean, theta one is actually they trying to say O1. Deletion is also O1. Lookup it means search is also O1. I mean, lookup it means find is also O1. There is no exist such data structure before. Uh, it's either in the linked list and the array. So, for example, array is good at for lookup is O1, but delete and insert is ON. But linked list is for insert deletion is O1, but lookup is ON. But same time, hash table is extraordinarily useful. As you can see, lookup is also O1, and then any operation is O1. This is a extraordinary interesting properties. So it's very, astonishing results. So wondering why we didn't just give up the linked list and the array. Actually, it's not like the simple, but if it is the depend on what's the data, your data structure, whether they can able to provide a hash function, that's another challenges. So as long as they provide as long as they provide such kind of hash functionality, then they will be give us such kind of performance. So that's very interesting. So very interesting. But there is another problem. We are gaining the advantage both by data structure while mitigating the disadvantage. Also fine. But hash table based on the hash function, right? Hash table has get the performance upgrade. We create a new data structure whereby when we insert data into structure, data itself give us the clue about where we will find the data should be needed to later look at F. The trade of that hash table are not great at ordering and sorting data. That's another problem of hash table. So it's cannot order, cannot sort. That's a problem of the hash table. But I mean, whereas linked list and whereas arrays, that's a natural nature of the array. But that's one very not good things in the hash table. So that's a problem. Same time they have a advantage. You can say that's extraordinary performance, but that one is not good because they cannot sort, right? Usually we are going to use sorted. After that we are going to use hash. We are going to use search algorithm, better search algorithm, binary search, right? That if I use hash table, I cannot use it. So that's a problem. There is a okay. So that's a direct compare with the hash table and the array list of the linear data structure, right? With the linear data structure. But we come back to why is that? So we trying to understand why is look like that, and then how we can solve that. First of all, we trying to understand what's the problem of the mechanism, right? So the problem of the data structure is of the hash function. As you can see, let me say, open the one article. Any hash function, any hash table or any hash table data structure, they actually based on the hash function. The problem is, first of all, what's the hash function, right? So that's the reason I'm asking. Hash function actually that the function that they can able to mapping with, for example, any formula can be mapped with another. So hash function can be, for example, let's say hash function like that. For example, this array size mod with the hash. I mean, hash is one of the function. Then they will be get the index. That's a hash function. But wondering, this is still not obvious example, right? What I can see is that, for example, what's the hash function? Use that one. For example, this one. Assume that I have a one data set, right? So, for example, in the there is a lot of data here. Then I want to find, in order to access each value, I'm going to calculate it by the index, but the index is not directly been accessed. Probably it's it's ordering here, but probably it's not the same. For example, here's hash function get the result of 13s, but this should be 20, and that would be 1. That would be I don't know. Maybe we can say that. Let's say I just give a visualized example. What I'm saying is those hash values mm, not we expected. Depend on the what's the hash function, they will be created. For example, that's a hash function, hash function, some formula, math formula. So math formula, any formula, for example, they will be used addition, multiplication, or divide, something like this. So any formula can do that, but main things that each time they will be generated unique ID, unique value. That's a interesting fact. Some function, some formula, right? So there should be any operation, a x operation. So x should be and divide, something like this. I don't know. But what's if the formula is actually, if the formula actually they will be generate value. The value should be unique, not duplicated, so they can able to identify each value. So that's the first thing. Second is the function should be computed very quickly, right? So that's very important. So then they will be save time. Otherwise, it's not meaningless, right? So what that means is if the function computation time very short by the CPU, then I will be get one value, and then I will be access by the value. I can directly pointer the exact value. For example, the value is 20, then they will be directly find ideas. If the value is 41, directly pointed to D. So it's extra, right? So that's a hash function, right? Another thing is that the hash function, as I said, there's a unique. They have to be unique, right? They have to be unique, but problem is how you can possible to some different value create the same value, right? For example, if it is using the different value, for example, a b divide and then multiply, add, I don't know. So finally get 20, the next times another value, but they also generate the 20. So that's being called collision. The value of the result of the duplication being called collision. So that's a problem of the hash function. So hash function has problem of the collision. So let me just introduce the collision problem. Okay. Right. There is a many collision technique, right? So you understand if there is a function being duplicated, the function value being duplicated, so it's not unique, then theoretically should be happening. So that's being called collision. The collision is many type of collision. Open. So there is a many kind of solution using the open hashing, closed hashing, and then linear probing, quadratic probing, double hashing. That's the solution of if there is a hash function happening the collision problem. So what does means? What does means the collision problem? Then what's how they can then use it? Things that um, things that the right. For example, let's say I give example. For example, that if I am let me just use, for example, this table, right? For example, here's this this is a serial number, this nine value of the 9 element. This is for we expected hash the k, which is the value of the hash function. That's a hash function. For example, that should be I mean mode hash function. They will be access 3. That's 1. That's 3. As you can see, there is a two things happening. So that's being called collision. But the problem is, can we avoid collision? The question is, can we avoid collision? Can we solve the collision? If we solve the collision, we don't need to change function. Actually, we continue to use it because actually we already find something wrong, but we expect to find solution. So how we can avoid collision, right? So collision, there is a many solution. As I said, linear probing is one solution. What's linear probing is, for example, if let's say there's a 20, right? As you can see, if there is another 20, I'm trying to tend to add one more index. They're trying to there is an empty place or not. Actually, there is not exist empty place. Then keep continue. Then there should be another place. Finally, they will be fine. So it's kind of linear probing. It means linearly try to find an empty gap. Then they will be able to insert it. So that's a linear probing. But at that time, they will be continue to add, they can able to continue to add this value. And then another value is quadratic probing. Quadratic probing is, as you can see, the like this. For example, if it's 20, then I will be added 21. Still, there's a even then in the next pointer doesn't there's no empty space. If there is a continuously no empty space, it's not efficient. What's double probing is they try to skip the double the size. For example, this is 20, then I double it, then 40. They go into directly index of 40. They say there is an empty space or not. So that should be if there is a third for for example, here's a index of let's say 40. Then what's doubling is for 40 multiply and oh, actually it's doubling. It should be quadratic is 400, right? So it is a 400. There should be empty space, so they will be, if there is a continuously, then that should be more efficient. Each time they will be skip double the size of the index, they will be trying to find. So if your data source is big enough, then that's also another function solution of the function. Doubling hashing is it is also another one. Doubling hashing is double hashing is actually they try to extend. They try to use array less plus linked less. So actually, what you're doing is let me just probably there has some example. No, there is no example, but fine. So doubling hashing is actually they try to create one linked list. Can we create one shape that represent that's an array? Then there is a many type of linked list. let's say a linked list, several linked lists. So what you're trying to do is, I mean, just want to simply assume that, I mean, this is a linked list. I'm trying to represent this linked list. This is a linked list, and then this is the array. So, for example, arrays, they will be continuously located. What I'm trying to do is, for example, I just want to divide it in many places. I mean, this is the second, this is probably third, fine. Okay, then this is the fourth. I mean, you understand what you mean, right? Hold on a second. Okay. So what do you mean is this is first index, this is second, this is third, this is fourth, this is fifth, this is continuing, right? So for example, if there is a, first, for example, there is a, A, this is a, I don't know, this should be C, I don't know. So just like this. So for example, but there's, for example, this is also indexes, for example, indexes, array start from the 0, right? So this is 1, this is 2, right? I mean, this is a 3, okay? You understand what you mean, right? So I mean, this is value, this is a k. This is array. So if I understand the A is not empty, but if there is another hash function, they actually find the place. The k is another. It's not the index, but the k values would say. I think I should. I think I should divide the two part. Would be better. I mean, there is a inside there has a k. This is a k. For example, four, okay, then blah blah, okay. So assume that this is index A. For example, they find that the k is 4, but another function also calculated this 4. Then what you're doing is not going to linear probing. Linear probing is they trying to find next one, but they trying to, if there is a same function result, they will be continue to locate in the linked list. They will be directly linked to the continue extended this is a zero index of the, so what's the zero index of the array, the value, they will be extend this another linked list. So what you mean is that they actually point to here. I mean, this is linked list. Linked list actually they can able to divide many, I mean, node. But I just want, I just need, I did a little bit. Oh, sorry. I think I shouldn't be use pointer. I think I should use. You just consider that is linked list. I'm sorry. Why they have without pointer? I mean, that's without pointer, right? I mean, that's linked list. Linked list should be as many nodes, and then in between they has a pointer that you understand. So same things. If double proving is actually if there is a collision happening, it's not going to. I mean, using the same detector, actually they extend the linked list, so they can able to without the function. You don't need to calculate again, but they will be extended. If there is same hash function, they say now same hash value, they will be extend this value, they continue to try to find this. That's another problem, not another solution is linear problem. Okay, try to solve the linear collision problem. So that's again, so we need a hash function, but hash function has a problem being called collision, and then collision has a solution. If, of course, any function should be possibility to happen same value. If there is happen, there is a solution. So what's the linear probing, clustering problem is another one. Then chain hashing, double hashing, and then quadratic doubling, it's also another. So that there is a many solution. So what I describing is there's can be solved. Those problems can be solved, right? All right. So that's good. So as you can see, if you try, we can solve the problem hash function, then okay, then it would be good to we can able to use hash function. We can able to hash function to use those data structure, which is that hash table, right? So right, okay, good. Now we are going to compare after that if we understand the mechanism of the hash function. And actually, hash table is hash function. As you can see, searches, insert, and then delete, and then average case is always O1 fixed time. But worst cases, they are linear problem. That's the probably depend on hash function. But as you can see, what's the average? It means average is always most percentage of situation, probably 90%, right? So it's useful. So as you can see, array is not good at array is good at for access, not good at for delete and insert. Linked list is good at for insert delete, not for access. So that's also has a drawback, but same time hash table has a good aspect. But there's a one problem that they cannot order, they cannot sort. So that's a problem of hash table. So when you think about front of your problem, you need to think about those properties, which data structure would be useful for you, right? So if you array should be good at for such case, linked classes in the green such case, but hash table is the threes insert, delete, and search as well, but there is no solution for ordering and sorting. So that's a problem. All right. I explained what's a linear probing, right? I explained how to solve this collision as well. So actually, hash function has problem, but they have a solution. So for example, linear probing, it means if they have had same value of the collision, then you needed to just move one place or another place, continue to linearly try to continue to discover the empty gap. Then they will just insert. That's a linear probing solution. But sometimes if there is a continuously being occupied without any place you can insert, then you need to think about how about we can not continuously find a place instead of skip some part. So that's being called doubling, or not doubling, quadratic linear probing. That's another solution. Then doubling is another solution, is that if there is a hash function is without trying to using, it's not, if you think that efficient, not linear probing and the doubling probing is not efficient, then you have a chance to use doubling. They can able to use linked list together with the array. So if there is a same hash function values happen, which is collisions happen, you needed to use that linked list as an extension, then without changing the hash function itself. So they will be extend this link from that point. You can directly access the access the linked list, then you can able to get advantage. So that's a hash function doubling function. So that's a second solution. All right. So probably we understand how's the hash function work. Then what's the problem of the hash function? Then as well as there's a hash table we already compared with the another linear data structure linked list and the array. Yeah. If you understandable, then next step we are going to focus on another algorithm. Any questions so far, dear student? If you without question, then let's continue to the second algorithm. Actually, the Rabin Karp algorithm, which is that one algorithm actually trying to use hash function to using the hash function to solve the problem, to collision. And then the Rabin Karp algorithm actually trying to find searching the string. What's a string is, sentence, word, letter, right? We try to find some letter or trying to find some sentence in the book or maybe in the article. So that's our problem. Then wondering, there is a many solution. One is a aggressive solution, which is say that we continuously linearly try to find. I mean, do you think it's efficient? Of course it's not efficient. There is a many solution they have. For example, let me say naive string matching is actually brute force algorithm. So what that means is, for example, you're trying to find the one value ATA in this letter, they will be going to compare one by one. You just look at this animation, right? For example, the ATA is in the last, but they will be continue to compare one by one. So first, it's not the same. Then compare, move one place, move another place, move another place. Okay, each time they will be just moved one place only. Then each time they will be compared 3 letters. So it means 3 multiply n, 3n. It's of course in linear time. Finally, they will match up. So that's a naive string, but it's a linear time. Complexity sometimes depend on the size of the length. They will be increased the quadratic time, because if the size of the very close to the size of the big size, then also is not good. So they will be in between the linear time and the quadratic time of the complexity. It's not good. So naive strings, brute force string solution. And then Rabin Karp algorithm, actually they do the hash function. Each time they trying to compare once. I mean, they try to, the 3 letter, use the 3 letter, just compare once. They just give the 3 letter, they calculate the hash function, then they going to, each time get the three letter to calculate it. They have using the Rabin Karp algorithm. So that's a Rabin Karp algorithm actually is a hash function used to rolling hash function, which is we used it, linear probing. It's looked like that. So what's the Rabin Karp algorithm? Actually, they used it such kind of they built it such kind of model, mathematical model, that prove that that's already been used it in the industry, whatever the field of the application. So actually, as you can see, this C is constant. A is a constant, C is the input character. keys number of character there as in the string we are comparing for. I mean, there's the first letter, second letter, third letter. I mean, so that's a mathematical model. Actually, this is useful to compare it. For example, here's a English letter. They have a 26 letter. You know, for example, A. In the A, for example, ABC, right? ABC's is hold on a second. And the Z will be C will be 26. For example, the Rabin hash alphabet, A will be 26, K will be 3. All right. For example, as you can see, we have a 26 letter, right? So 26 letter, then they try to use the constant is 26, the size of the length of the letter, and the whole possible appearance of the letter, unique letter. Then the keys, you trying to find the size of the word, for example, ABC size of the key is size of 3. So if the size of 3 is index, if it start from 0, that's last index is 2, then is 1, then is 0. Then that's algorithm. So for example, there is a 3, it's the first one, multiply the size of letter, then your index of the key, this is the ABC of the size 3. The second is the 2 multiply 26, and then this key size of decreasing. This is very that's the kind of algorithm actually worked at Rabin Karp. This is used to prove the performance better. Rabin Karp actually they give them n multiply m time complexities, n size of the length, m was try to find up the length of the letter, which is that, for example, ABCs, this m is 3, and then the letter, for example, 100 means this should be 300. But it is better than quadratic time. For example, it is letter is 100, they will be find element in the worst case should be at maximum as quadratic time, which is that 100 multiply 100 is 10,000, but they will be just used to 3. So for example, at most they will be 3 letter will be at most they will be used 300 times. So Rabin Karp is useful. The worst case is n multiply n time. It's also less than probably, they say that worst case, and then of course average case should be better than that. Okay, so that's Rabin Karp. As you can see, if this linear probing is quadratic time, for example, 100 element, they will be spent, worst case is 100 multiplied 10,000, but using the Rabin Karp, they will be used 300 times in the worst case. So that should be useful, right? If you any interested, this house, there is a more article you can reference for. Okay. So next question is maybe probably how can we use Rabin Karp algorithm in the coding, right? As you can see, there is a search. They give the character. This character. This trying to find of your. This you're trying to find your letter, and then yeah, right. So let me say start from the main. So main is, for example, that's the source of the for example letter, but you're trying to find the gig. There should be gig appears 2 times. And hold on a second. Right. So here's I just give the maximum in it because you don't know how much. and then they will be going to search it. What done is actually they will be print out this they found in the first index, and as well as find the 10 index. So it means actually they found it in the two place. Yeah, in the n plus n time. I mean, best case n plus n time, worst case is n plus n multiply n time. So it means, for example, 100 element, 100 element, you're trying to find one word, three letter of the word. I mean, worst case is 300 times they will be found. And then best cases they will be found in the 103 times they will be finding. But if you're using the linear naive search or brute force algorithm, they will be 10,000 times will be spent in worst case. So it is, which is that better than worst case, better than linear program approach, which is very good algorithm we can recommend, right? All right. So as you can see, search, first of all, that's the size of the length of the, it's m, this is length of n, text is source, then I mean p is pattern, right? T is the text, h is the one. Then first of all, they trying to use I mean h is hash function. They trying to calculate hash function with the h multiply d. These words come from, where does these come from? These 256, this is a fixed, I mean, constant value. Okay, they're using the constant value. They're trying to find, because the length of the 260 is length of the char, actually, because we're trying to compare with the letter, English letter of the char, of course. The char size of the 2 power of 8, right? And then, as you can see, here's a one loop, and there's another loop. It's probably it's a quadratic time, but there's also, they can try to escape it, so it should be less than quadratic time. So you can compare, you can, as you can see, there was not the linear time, there will be less than linear time, size of the array will be run it. Then also this is from 0 to n, so it means from n multiply, its worst case is n multiply m, should be n is 100, m is 3, so it is most is 300. But linear programming is the both are actually, they will be n, m is also very close to m, then there will be quadratic time complexity, which is the 10,000 in the worst case. So that's one of the coding. You can use it, you know, any program language to run the same things. You can reference it from the article, as well as other language you can find it based on your interest. So I think that's yeah, one of the example you can use reference for it. All right, so that's the time to today's lesson. I hope you have a question.